next we have the distance formula and the midpoint formula. If we had ordered pairs, x and y, there's the distance formula. The only thing we do different is we now add our z's. So you still subtract to find the distance and square it, and then it's the square root of the sum of those things. Midpoint, there's the midpoint between two ordered pairs. This is the midpoint between two ordered triples. You find the average of the x's, average of the y's, average of the z's. The midpoint, if you remember, is what is halfway between two, and it doesn't matter if it's ordered points or ordered triples. The midpoint is what's halfway in between, okay? So here's two ordered triples. I'm gonna find their distance. So my distance, and now these are not like vectors. It doesn't matter which is my first point and which is my second point, okay? But I'm gonna do -9 minus a -6 squared plus -2 minus 6 squared plus -2 minus 3 squared. Now, a common mistake for just the plain old distance formula is for somebody to go, oh, well, I have -9 minus a -6, that's equal to a -3 squared. Now I just made two mistakes. Number one, this has to stay in parentheses. Number two, what ends up happening is people often ditch that radical because they're just kind of doing some chicken scratch work, and then they never bring the radical back. So make sure that you use parentheses and don't ditch your radical. This is a -8 squared, and this is a -5 squared. So we're going to get a big, relatively big number. This is going to be 9 plus 64 plus 25. Try that again. And so I get 98. So the square root of 98. 98 has a perfect square factor of 49. It's 49 times 2. So my exact answer is 7 square roots of 2. Just make sure you read the directions as to whether it's an exact answer or a decimal approximation. Midpoint, I find the average, -6 plus -9 divided by 2. The average, 6 plus -2 divided by 2, and the average, 3 plus -2 divided by 2. So my midpoint is going to be at a -15 halves. This is going to be at 4 halves, or 2, and this is going to be at 1/2. And that's it. Okay.